Hello and welcome to LunchBytes. Thank you for joining us. If you're joining us live or demand, it's brilliant to have you here today. So my name is Ty Brennan. I'm a cloud solution architect in the UK, working on our digital and app innovation area, which is mainly all things related to the developer side of Azure. And you're joining us on LunchBytes. So LunchBytes is a technical live stream where we get sort of the latest and greatest of technology from Microsoft in the UK and try and publicize that and showcase it to everyone watching live and on demand. So as it's a live stream, there's a couple of things we just want to ask that you make sure that you're aware of others, be welcoming and respectful, and please be understanding of differences, be friendly and patient, be open to all questions and viewpoints, and be kind and considerate to others. So for our full code of conduct or to report an issue, please go to aka.ms/eventscoc. Now, this is the whole LunchBytes team. It's just me today. But fortunately, we're joined by a couple of great solution architects in the UK. So Simon and Hasifa, I'm just bringing you up on screen now. So we'll be talking a little bit about Azure High Performance Compute. But firstly, do you want to give an introduction to yourself, Hasifa?
Yeah. Hi, everyone. My name is Hasifa, and I'm a cloud solution architect, just like Tig, but my focus area is more around infrastructure. So migration, hybrid, compute, storage. I look after all of that for my customers. So I'll pass over to Simon.
Thanks, Hasifa. So yeah, like Hasifa, I'm a cloud solution architect in our infrastructure side of things. So Azure infrastructure, as Hasifa said, storage, high performance compute. My specialisms and interests are in high performance compute and Azure Virtual Desktop, which I've been doing large scale deployments of for the last few years. So hopefully today to talk around high performance compute.
Great. Well, it's brilliant to have you both. I'm really looking forward to this session on HPC. Before we jump into the content, just a couple of things for our audience. We will have an opportunity for Q&A live at the end of the session. And so this will be in about half an hour, 40 sort of minutes time from now. So please do send in your questions during the session and we will make sure to bring those up towards the end. So Simon, I'm going to hand over to you now.
Sure. So Hasifa's going to do the first couple of introduction slides for us. So take it away. Thank you.
Yeah. Firstly, I do want to apologize because I do hear my mum yelling my name downstairs. So if you do hear her, I do still live with my parents, so you will hear them just in case. I apologize for that in advance. But yeah, before we get started with, talking about kind of like HPC workloads in general, and also talking about the accelerator, Simon and I just wanted to introduce a key concepts for HPC so that everyone is level set when it comes to the terminology. So if you don't know it, this is a great way to learn. If you do, this is a good, way for you to revisit those terminology as well. So when we talk about high performance compute, we are essentially talking about a capability. High performance compute is not a thing. So the whole concept is like if one computer can solve a problem, 5,000 computers can solve it quicker. So let's say that you have 5,000 computers, and you're using a piece of software to pull that resource together. We can then tackle problems more efficiently and quickly as well. And that's what high performance compute is all about. So a few different words or terminology that come up is compute. I am an infra CSA, so we talk about compute a lot in my job, but compute capability in essentially just means like you have the CPU and memory. That's normally what you think of when you hear the word compute, right? So they're often referred to as nodes, and they're usually interconnected with high-speed, low-latency network. And that is just so that they can work as one unit for a defined job. And the network is often hooked up with RDMA cards, and this just enables high-speed, low-latency networking, for example. And this can be done by InfiniBand. You also have parallel file systems. So parallel file systems, they usually ensure that multiple compute nodes have the sufficient performance to read and write data at massive volumes. For example, Lustre, NetApp, BGFS, if you've heard any of these providers, those are parallel file systems. So all of them try to eliminate and solve traditional I/O bottlenecks. So these file systems often involve separating metadata from block storage. And what they do is they splice the data across file server nodes to increase the throughput and decrease latency. And this really helps when you're trying to tackle those, huge simulations, for example, and problems. You also have the scheduler. Now, the scheduler is usually it's basically just an interface for users to submit jobs into the HPC cluster. So when we talk about the scheduler, we normally have, it's just software really that implements a batch system on a HPC cluster, for example, and it stores the batch jobs. It evaluates the resource requirements and priorities, and it also distributes the jobs to suitable compute nodes as well. And then you have the accelerators, more to do with machine learning, to be honest, but those are optional accelerators like GPUs that you have as well. So we talked about common terminology. I guess like now we can move on and talk about the two main type of workloads that we come across when we talk about high performance compute. So the most common ones are tightly coupled workloads and loosely coupled workloads. So when you run a job, for example, across multiple nodes, like each node can keep each node would have to keep, when you're talking about tightly coupled workloads, there needs to be a way that each node can keep updated on the status of other nodes. And the messaging, the message passing interface specification achieves this. So the MPI is basically just a standard to enable HPC to communicate on clusters of compute nodes when they're distributed, or shared or in hybrid memory model, for example. So there are many MPI libraries that exist. You have OpenMPI, you also have Intel MPI as well. And when we talk about tightly coupled jobs, we're talking about kind of like, let's say, computational fluid dynamics, which is basically looking at fluid particles and how they affect each other. So I guess, Simon, this is what we're going to be looking at later, right? This is what...
That's correct, yes. Yeah, we'll do a simulation of a CFD workload. So just see how the fluid particles affect a particular object. So.
Exactly. And in this case, we're looking at a motorbike. So very exciting. So that is going to be our live demo. And also things like weather prediction, reservoir simulation, as you can see on the picture on the left, is all things that you can run when it comes to tightly coupled workloads. You also have loosely coupled workloads. So loosely coupled workloads, they're also called embarrassingly parallel workloads. I've just learned that recently. So when you have loosely coupled workloads, they're jobs that can run subtasks independent of each other. So they don't need node connectivity like the tightly coupled workloads that you have. So for example, you have 3D image rendering. So you can have each frame or chunk that can be performed independent. And then what happens at the end is the chunks and the frames can then be brought together. So they are independent of each other when it comes to 3D image rendering. So that is also a loosely coupled workload. You have genetic programming, and also if you're familiar with Monte Carlo algorithms, those are also examples of loosely coupled workloads. So yeah. Okay, so when we talk about how on-premises infrastructure can be limiting and why high-performance compute on cloud is, effective as well as needed for customers, it's because of just the functionality of cloud basics, right? Whenever we talk about cloud in general, all of this comes up. You don't have to foot like huge upfront capital costs to use high performance compute on the cloud. Hardware also becomes very obsolete quickly if you're using on-prem infrastructure that you own yourself. And you will have a lot of operational costs, right? You need to make sure that those servers or infrastructure or bare metal is looked after. You need security, you need cooling systems, you need all of that. And that's where cloud comes in. Cloud providers like Azure take care of that. So you just focus on the functionality, right? So that's why cloud is important. Now, the slide was changed, which I'm taking as I need to move on, so I'm quickly going to do it.
Apologies, that was me. But no.
No worries. I got the hint, Simon. Don't worry. So when it comes to solving any HPC or AI workload at any scale, we just wanted to show you the examples of virtual machines that you can use on Azure itself to run those either like coupled or loosely coupled or tightly coupled workloads that we were talking about. You have the burstable series, you have the specialized VMs for specialized workloads. Burstable just means it increases as capacity as you need, etc. You have the general purpose, high memory, depending on what you need, right, for your workloads themselves. So that's on Azure. So when we talk about high performance network services, so previously we talked about the message passing interface, and that just is basically having that interconnected capability for HPC nodes, right? Making sure that they can communicate with each other at low latency, high speed, etc. And that's what InfiniBand helps with, to annihilate those silos that we were talking about. Now, using technology such as InfiniBand, you can also have like Azure offers interconnect speeds of up to 400 GBs between compute nodes as well. And then when we talk about ExpressRoute is just enables high-speed connectivity to your on-prem bare metal resources, for example, if you need to, just on-premise resources as well. Cool. So when we talk about management of HPC workloads, we have two ways to do it. You have Azure Batch, which pretty much is basically like, your all-up way where you don't really, it manages the scheduling for you and all of that as well. So Azure Batch is useful to run large-scale parallel high-performance computing batch jobs. So Azure just basically creates and manages a pool of compute nodes, and it installs the applications that you want to run, and also allows you to schedule the jobs and run on the nodes as well. So there's no cluster or job scheduler that is needed for this. Batch does it for yourself. So so you can install, manage, or scale, and you use batch APIs and tools in order to do this, and as well as command line scripts and Azure Portal to configure, manage, and monitor your jobs. So that's an all-up Azure solution, basically. And then when we talk about Azure Cycle Cloud just enables you to access big compute resources that Azure provides. So it allows you to basically use your own scheduler if you are using it. I can't decide between scheduler and scheduler. I'm just going to say both. So I think I'm going to say both. Cycle Cloud runs compute clusters. It is designed to allow line of business IT groups to provide easy access to cloud clusters for their users, right? So it also features tools for managing the flow of data and compute jobs. And the most important differentiation would be that you can use your own scheduler, for example. So now I will pass on to Simon.
Thank you, Sita. That's a really good overview and level set, and hopefully that sets everyone up for a bit more of the terminology that we'll use in the demo. So Azure itself has a really rich HPC ecosystem. We support a lot of ISVs, and a lot of ISVs have native SaaS offerings on Azure, which can run things like Ansys, for example, Siemens NX workloads that third parties will use, which leverages resources that Azure can provide. We've also working with a number of partners. So if you wanted to get up and running quickly with sort of enterprise scale ways to deploy and scale out HPC clusters, we work with companies such as Rescale, NetApp, NVIDIA to get you up and running as soon as possible. And we have great guidance, frameworks, and support effectively for these platforms. Now, something that customers have asked for consistently is us integrating quick and easy guidance to install HPC as per best practices with our Azure landing zones. So Azure landing zone methodology goes through the sort of 7 pillars of core functionality for any Azure platform to make sure that it's scalable, governable, secure, and you can basically continue to add workloads to it without affecting previous workloads or your actual topology of your Azure setup. So there are now 3 industry standard workload accelerators, we call, for Azure landing zones for HPC. So those are finance, manufacturing, and energy. Now there will be more released soon, but they give you guidance on how to deploy those workloads in a best practice manner into an existing Azure landing zone. There is also a way to get up and running pretty quickly with Azure HPC. If you want to test it out with Azure Portal and full functionality, we have something called azhop. Now, azhop is the Azure HPC on-demand platform, and what it does is it gives you options to deploy a complete HPC cluster with all the components you need. You can chop and change what you need, and then get up and running quickly with individual user access, job submission, portal, and monitoring. So with azhop, there's a GitHub repository you can go ahead and install and deploy to your Azure subscription, and it gives you things like a secure NetApp files repository for user shares, a Lustre cluster, so you've got a high performance parallel file system for your nodes to connect to, a job submission engine and scheduler. So by default, it uses PBS, but you can choose any other scheduler, and it hooks into Cycle Cloud there for that cluster orchestration and management. You also get some monitoring features such as Grafana dashboards, policy lifecycle management for storage through Robinhood, and there is also some ways to actually connect remotely to visualization nodes using Guacamole, and that can be substituted if you wanted to. You could use something like Azure Virtual Desktop, but you have a few options there to go through. So what we're going to go through now is it's actually going to be a pre-recording that I'm going to talk through because it would take too long for this LunchBytes session, but it's an example of what deployment of azhop would look like. So effectively, you would go to the azhop repo site, you would have a Windows subsystem for Linux virtual machine ready, or a deployer VM that you install, which is based on Ubuntu, and you go ahead and clone the repository. From there, there's an install script to install the dependencies. Now, there's a lot of dependencies that you need to install azhop, primarily because there's so many things that come with azhop that you need to go ahead and install. Things like, obviously, you've got your Lustre, your Cycle Cloud, Grafana, etc. So the dependencies you're going to need are pretty great. So that's all scripted for you. You go ahead and do that deployment and install those prerequisites, and then you can go ahead and do the first part of the resource deployment within Azure. Now, the resource deployment itself at the moment is done using Terraform. So once those prereqs are installed, you'll be going ahead and amending a config file to suit your needs, and then doing the actual Terraform deployment itself. Now, the Terraform deployment itself is based on the resources that you provide within this config file. So this config file has things like, do you want to make sure everything's monitored? Are you sure you want to deploy ANF, so Azure NetApp files? You don't have to. Do you want to use existing resource groups, create brand new ones? It also hooks up to an Active Directory domain for user access. So you can choose if you want to use an existing one or create a new domain controller with AD domain and map those users to user IDs for people to log in and submit jobs to. So as you can see here, what we're doing now is we're doing that Terraform plan to make sure that the resources we're going to add in Azure are all going to be okay and our subscription is set up correctly. So because you're deploying so many different services, there are a number of Azure resource providers that you need to enable in a subscription. And there is a list of those within this repository that you can go through and have a look at. We found it easier to deploy this using a fresh Ubuntu VM because of those dependencies. We found that if you're using an existing virtual machine that you've had previous dependencies on, sometimes you might get a couple of errors. So if in doubt, deploy a fresh virtual machine, use a code space, or use Subsystem for Linux but just make sure those dependencies are installed correctly. Now this is going ahead and it's using Terraform to deploy the resources to Azure. So it's going ahead and creating the VNets, creating the domain controllers, virtual machines, subscription providers, and NetApp volumes. Now, once that's done and my resources are in Azure, they're all powered on, I'm going to go ahead and run this install.sh script, which is based on some Packer scripts to configure the virtual machines that I've deployed. So that goes through and configures my Active Directory domain controller. It configures things like the volumes for Lustre and the volumes for Azure NetApp files. This process takes around 50 minutes because it's quite an intensive process to actually go ahead and configure all those individual items. It also sets up all the authentication, Cycle Cloud, etc. So the deployment itself is complete, and what you end up with, I'm just going to show you now, is this on-demand portal. So if we do a refresh, you can see that I've got here an on-demand portal with a user that's logged in. Now this is could be an Active Directory domain user, for example, that's logged in within your organization. And from here, they have access to most of the capabilities that were listed within the HPC platform that we have on Azure. So what you can do as an end user, you can have a look at your Azure NetApp files directory for your home files. So you can make sure any projects you're working on, any pre-processing jobs, etc., you can do and save into Azure NetApp files. And you've also got the option to have a look at the high performance parallel file cluster files as well. So if you've got access to Lustre and you wanted the nodes to also have access to that, you can upload files and jobs that they can have a look and do. There's a job mode, so if you wanted to, you can compose a job, which would submit jobs then into Cycle Cloud, and then that would allow you to automatically spin up and spin down things. So there's some templates in here. If we have a look at templates, you can do an MPI ping pong test, which will spin up a couple of virtual machines that are interconnected with InfiniBand, and it will confirm that they can communicate with each other. But from here, you could actually load in anything you're going to submit to the PBS scheduler, as it were. And make sure that it's doing the right archival settings for storage. Now, when we go back into the azhop dashboard, you've got a few other options here as well. So you've got your job composer where you can run jobs from. You've also got cluster shell access. So if you prefer to run jobs from a cluster shell, you've got things in here such as access to the PBS scheduler. So that means you can run things like qstat, qsub, and you can submit jobs and connect to interactive sessions in a job if you wish to. You've also got access then to deploy certain features. So if you wanted to, you could deploy a Linux desktop with a GPU or without a GPU, and that desktop will then be connected up to your Lustre file system and your NetApp file system, which means from there you can review the results. So you can do post-processing and visualize any results you run for a CFD job, for example. And when you deploy these desktop machines, you can actually specify a duration. So I only want this desktop, for example, for an hour. I would go launch. And what that would do is it would create a job and it would submit that into the Cycle Cloud software, and it would spin up the virtual machine through Cycle Cloud using PBS as a scheduler. And just to show you what I mean there, if I go into the Cycle Cloud portal itself, we should see in a second that the job that I have submitted has come through to Cycle Cloud. There you go, look, and it's creating that virtual machine that if I left it long enough, it would be able to connect to, and I could browse and have a look at my results files. So if I want to do anything else through this azhop portal, I've got a few other options. We've got a Grafana dashboard, which means that you can do in-depth monitoring of your resources, both in the cluster and outside of the cluster. So if you wanted to have a look at the infrastructure, you can have a look at some of the dashboards to do with sort of a heat map on resources, see if the storage is working correctly, see if there's any sort of bottlenecks there. So it's pretty good. That's set up by default. And then I think I mentioned before that for Lustre, there is a Robinhood policy engine dashboard. So Lustre is quite expensive as a parallel file system if you're running it for any length of time with a lot of data. So what you might want to do is set up something like Robinhood, which basically archives off less used files or files that aren't hot anymore into blob storage, so you're not paying as much to actually keep them within that parallel file system there. So all of that is included by default, and you can go ahead and log into your interactive sessions and go from there. So what we'll do now is we'll go through and this again is going to be a pre-recorded demo of what it looks like to configure a HPC job through that shell. So we'll be loading up a HC44RS virtual machine, and then executing a CFD job using a program called OpenFoam. So that's going to be a particle job that's going to simulate airflow around a motorbike, and then we'll be able to visualize those results in a node that's been deployed in the method I just showed you there. So here we are, we're going to set up a couple of compute nodes. So I'm doing an interactive session using the PBS scheduler through that shell session in the HP On Demand portal. And you can see that CycleCloud takes it on, it spins up the node, puts in any sort of dependencies that I wish it to. And that's going to go ahead. And once that's spun up and once that's running, it will connect me through on an interactive session to that node. And from there, I can submit jobs, I can install dependencies or install any prerequisites that I need. So I'm using QSub here to create that interactive session with that HC44RS machine. And then we should be able to connect. And you see the schedule is ready, and I'm then in the node itself. And what I'm doing is I'm going to check for any prerequisites. So for example, I know if I want to install OpenFoam, there's a way to do that and a tutorial on that azhop website, which is where I need to make sure I have the SPAC package manager installed. So I'm just checking it's installed on the node and setting up the environment variables there. Once the environment variables, as you can see, are being configured and set up, I'm going to pass it over to Hasitha to finish off that OpenFoam installation. So let's just wait for this to finish. You can see that it's setting up the compilers and those variables there. And I should be able to pass that over. Okay.
Perfect. So at this point, you can basically see that we are loading the prerequisites into the cluster. So in this case, installing OpenFoam on the nodes to run the motorbike tutorial job. That's what we're doing here. And then you can see once that the prereqs are set up and running, which can also be defined in a job task, basically, the motorbike solve operation completes on this node. So it's just going to take a while, but that is initially what's happening here.
Yeah, that's correct. So you're creating that directory, that user in the Lustre cluster. It's running that motorbike job. And you'll see in a second, it will then submit the job and it'll execute that. Now, what you can do if you schedule this properly in a job using the on-demand portal, CycleCloud will handle the orchestration of the node for you. So it would spin up, solve the job for you, and power off again. So you're only paying for what you use, and that is the advantage of running these services on the Azure cloud, is that you're doing a pay-as-you-go. You haven't got a cluster that's on all the time. You do have the option to if you want to, obviously, but a pay-as-you-go model is more flexible for you. So that job is now running, and then
and then go for it. Did you want to?
No, please carry on. It's
I was just going to say that the results are then just shared to the Lustre share, which can then be accessed and visualized through a Viz node. So I think through the on-demand portal, which is what's happening here. So Lustre, as we just mentioned before, is a parallel file storage system, and that's what we're using so that you can access your data to visualize it, which will come up in the next slide.
Yeah, so within this visualization node, this is where you'll see by default, you've got access to those Lustre file shares, you've got access to your home drive within the NetApp files repository, and you can choose to install stuff by default on images if you wish to, but for example, we're going to use PowerView on this visualization node, and there is a small recording of what it would look like once it's installed, which is you can open those results files, PowerView is open, and then you can have a look at the motorbike and where the airflow will impact the motorbike the most based on the sort of results output of the equation that you just solved there. So once that's done as well, because it's a visualization node created by CycleCloud, it's fully dynamic. You've specified that session for an hour, but you can specify it for as long as you want. You don't have to delete it either. It can sort of power off in a temporary state, but essentially you're then powering off and deleting it by default. So you're only paying for the resources you use while you use it, rather than having that there all the time for you to log into. You know, your network storage, etc., is always going to be there. So effectively, the nodes that you log into can be ephemeral. They can disappear. They don't really store any data or need to be there only when you need them.
Yeah.
Okay.
Just before we go on to the Q&A, I guess I just wanted to mention that this is exactly why the Accelerator was created, azhop in general, because something to highlight is customers really want to use high performance compute, but sometimes it's really hard to understand where to get started, what resources I need to deploy, and that takes time. It takes effort. And what we are trying to do with this and the Accelerator is we're trying to decrease the amount of time for you to play around with simulations or solutions or workloads that you want to work with. So that's what the Accelerator is there for. And right now, I think we have particular scenarios for about 3 industries, including finance, and I think what were the others?
Manufacturing and energy. So yeah.
Manufacturing and energy. So this is why we created the Accelerator, so that customers can use the solution faster and give us feedback as well. So it's an ever improving process, and we're looking to make it better so that customers get the most use out of it. And that's why we're doing this.
That's right.
Brilliant. Well, thank you both for jumping through those demos and taking us through those slides to sort of level set us at the beginning. I guess if we jump into those sort of question time now at the moment, and previously at the end, you kind of hinted towards the opportunity for people to go and learn more about this kind of stuff. So the first thing that I really wanted to ask is, where can the audience go to find more information about Azure HPC on-demand platform?
Sure, yeah. So we've got our Microsoft Learn site, which is where most of these documentation for the Azure Landing Zone Enterprise Scale HPC Accelerator stuff is. And then we've also got azhop. And azhop is that GitHub site. If you search azhop on Bing, it'll come up as the first link. And that gives you the full sort of azhop repository information and documentation. So.
Yeah. And also something that really helped me just to learn about lots of different topics. I'm not pushing LinkedIn Learning. It's just a way that has helped me really. There's quite a few informative sessions on LinkedIn Learning that you can have a look at about high performance compute in general when you're getting started on it. And also there's a ton of YouTube content out there on high performance compute in general. So yeah, depends on how you want to go about it.
Great shout, Asifa. So the other thing is, you're mentioning azhop, and you sort of showed us a bit about it. Is this officially supported by Microsoft?
So azhop itself started off as a community project. It's being brought into the fold of Microsoft. So what happens is, if there is an issue that you notice with the repository, or you want some support, then you can raise a GitHub issue, and there's an SLA for a response, not a fix, just a response. However, each component of azhop that gets deployed is effectively an Azure service, and that is backed by an SLA. So, if you're deploying Cycle Cloud, if you're deploying anything like the Azure NetApp files, it's the standard Azure SLA you'll have linked to that anyway. So what we're doing with azhop is just bringing it all together, amalgamating it in a portal. The actual components behind it, standard Azure support. So, yeah,
it goes back to what we said on slide 1, which is that high performance HPC is not a thing. It's it's a multitude of resources working towards a workload that you want to run, and all of those resources, like Simon said, come with their own SLAs, right? So azhop is exactly that. It's a multitude of resources all working together. So yeah, it's not just one thing that we can offer SLA for. So.
Yeah. Good point. I think that kind of reminds me, one of the bits I enjoyed earlier when you mentioned the likes of Terraform and how we were using that to make sure that all the different resources are deployed correctly, and offering some good advice around make sure you use a clean Ubuntu machine.
Yeah, I think that's great. Yeah. I think in the past we've seen some customers say they have issues with deployment, and it's usually always been due to the Ubuntu VM or whatever they're deploying it from. The dependencies haven't been set right, and that's usually what you need to make sure is correct. So,
cool. So there's a lot of services that are involved. So my mind sort of goes to the cost side of things. So how essentially are customers charged for using this service?
Sure. Well, Cycle Cloud itself is run effectively on an IaaS VM. So while you pay for the compute time of the ISVM, you don't pay for the Cycle Cloud service. What you're paying for is the consumption of resources. So Cycle Cloud will orchestrate and spin up virtual machine clusters, or whatever you're spinning up. The compute time of those VMs will be chargeable, but the Cycle Cloud service itself, bar the IaaS infrastructure it runs on, is effectively a free service. And that's the same as Azure Batch. So Azure Batch is a free service. You're paying just for the compute, storage, and network time of the resources you're using to consume through it, if that makes sense.
Yeah.
Great, that does make sense. And just for anyone watching live as well, it's now an opportunity to send through any questions. If you do have them, we'll bring them up now. So one of the other questions that I wanted to go into personally is you showed a pretty cool diagram there of the motorbike that was made. What sort of, I guess, firstly, from an experience, if you don't have Azure HPC, what's this process like? Is it something that takes a long time? And how much of a difference does using Azure HPC make to that overall process for a developer?
Yeah, so I'm happy to take this one. But effectively, when you're doing particularly a CFD job, so if we're talking about the motorbike job, for example, or any sort of computational fluid dynamics job, you often have a process you go through. So you do a pre-process, a solve operation, and a post-process. So with an end user, if they're doing a pre-process operation, which is where they're trying to basically solve a calculation of airflow around a certain object, that is done using a process usually called meshing. So that pre-processing is done on a visualization node or a high-powered node using software such as ANSYS or something like that. And that basically calculates the object that you're going to apply an operation to into a load of triangles, a mesh effectively. Then the solve operation will basically take that mesh and then fire the particles at it and do the complex mathematical computation around that. And that happens often on the HPC cluster itself. So the end user could potentially spin up that desktop that they would log into, so that visualization node, and then they would do their pre-processing, submit the job through that on-demand platform to the HPC cluster. So that would then do the solve operation, and then the post-processing, so that's the visualization of results and making sure that it's as accurate as can be, is all done again on that visualization node that they can spin up and down. So for end users and engineers who use laptops or devices, or they might be remote and they're not super powerful, doing things like meshing is really time consuming, and actually being able to spin up a high powered workstation really quickly on Azure is a great benefit to speeding up the whole process and the time to solve. So not only are you spinning up a sort of quicker way to solve the operation, you're also spinning up a quicker way for the engineer to do the sort of initial work as well. And you're only paying for it when you need it. And that's great. So it means that organizations and engineering teams can be cross-charged. They can own sort of their own department and what they want to run, rather than relying on a single cluster or a single instance that the whole business uses for different purposes, and being stuck in a sort of scheduling nightmare that someone has to manage. So.
Yeah, and something I would just add from previous customer experience that want to deploy HPC workloads is development is not an isolated approach, right? We all know this. We work on this, right? So there's a lot of operational excellence that goes into running HPC workloads as well, because something to take into account is HPC is high performance compute, and anything that has high performance in front of it has costs associated with it, right? So operationally, that's a lot of time that is included to consider what the best resources to use are, what are the most efficient virtual machines, are we right sizing the virtual machines, is the cost optimization there in place to make sure that your simulations are not overrunning when it comes to budget. Other consideration also include, and this is where the accelerator actually comes in. For example, let's say you're working on chemical simulations to create new products, right? You're working on, let's say, a shampoo or anything like that, and you need high performance compute for that. A previous customer just spent a very, very long time on the pilot for it because they were not really familiar with the concepts as well as how to use it on Azure specifically, right? They were sold on Azure as a platform, but we're not really sure how high performance compute fits in on it because, it's pretty new on Azure, right? And how we use it and the functionality. So I think this accelerator definitely helps with that piloting phase of it. And Simon went into the technicalities of it for sure about the process. But there's a lot that goes into it when a business is considering how they want to do it. Because latency is also how fast do you want the results? When do you need the results? For example, weather computation, how fast are the results that you need those? So stuff like that.
And it's a great point just on cost quickly when you're saying how fast you need the results. There are some times when engineers would be more conscious of cost. So they don't want the result necessarily quickly. They just know it needs to happen over a weekend. So you can use with Cycle Cloud the option for spot VMs. So that's VMs that can be evicted if if there's a high priority demand for them, and you're paying a lot less for them. So there's a lot of flexibility within the platform that allows you to optimize the cost based on the demand. So.
That's great to hear. So that's kind of going to be one of the things I was going to ask next, was around the accelerator here is able to help people get started and to really reap the benefits. But I guess, what was that optimization story? So you've mentioned there, Simon, that there's spot VMs that you can use for longer jobs over a weekend. Sifa, you mentioned essentially an opportunity around like the cost side of things, optimizing. Is that a separate process? Is there typically, we might have like the well-architected guidelines for other areas? What's it like in HPC?
It's exactly the same, right? So it's like whatever workloads you're building on the cloud or migrating into the cloud, cost optimization should be at the beginning of all of those processes. If you look at like cloud adoption framework, for example, from a Microsoft perspective, which talks about the steps you need to take to make sure you have successful onboarding onto the cloud, we are talking about having governance and management established from the beginning of that process. So when you're even planning the pilot, for example, like, have you got the budgets in place? So in Azure, you can set budgets, for example, that so your subscription doesn't exceed that budget, and you're told when your resources are exceeding those budgets. Do you have the right tagging in place? Are you tagging your resources so that you know what you're paying for those resources and what workloads are causing that? So all of that should be considered when you're actually planning on testing out simulations on high performance compute, because it's not something that you can just do after. That would be really difficult because you'll spend a lot and then you're like, oh God, no, I need to optimize, right? So, as CSAs, we tell our customers all the time that this is something that they have to do from the beginning. And there's a lot of resources that you can use to do it, and a lot of support and help from us, as well as other resources here that can help you out as well with that.
Right.
So I was just going to say, on the technology side of things, Cycle Cloud has built-in cost management, so you can set budgets in there as well. And I touched on it before on the on-demand platform. Storage is a huge cost, right? So if you're using a parallel file system, it's expensive. That Robinhood policy engine, it's an open source engine, but there's other options available, will help you archive files off of that Lustre file system if you're not using them. Pay for what you need, not for storing data in really high performance storage at all times, basically.
Cool. Yeah. So the final thing that I wanted to ask you both is really around some of the examples that you've kind of already talked about a little bit more, just to leave the audience with some ideas of where the potential of this service is. So you mentioned during the demo we had like the motorbike CFD, and then Sifa, you mentioned around sort of like the chemical side of things and testing that. Are there any other examples that you can share that sort of really tell the story of what's possible with HPC, just from your experience, the both of you? So Sifa, I'll start with you.
Well, I think, we already talked about the weather, right? Weather predictions and all of that high performance compute is used in that way. When we're talking about high performance compute, I work primarily within the CPG, so consumer goods and retail space. Retail isn't really a known area for high performance compute, but there's a lot that you can do there when it comes to customer analytics, for example. So we are collecting more and more data when it comes to like our customers and what they're consuming. So can we use it for data analytics, like high performance, like data analytics, to identify what the next big thing is? I don't know what it is yet within retail, what they would use it for. But I think retail is an area that's growing from like the artificial intelligence perspective. Yeah. I don't know if that made sense. I think, Simon, I don't know if you've seen something in retail when it comes to the application of AI and HPC, but I think that's coming. So,
yeah, definitely. Yeah, well, I'm based in the sort of manufacturing side of things. So there's a lot of global manufacturing industries that have offices in Asia, the US, APAC and UK, for example. And what they end up doing is they've traditionally had very slow engineering and manufacturing processes due to the fact that they're so disparate. File transfer times take a lot of time, etc. So by centralizing remote workstation access using something like Azure Virtual Desktop and then cluster access, so the storage is in the same place and the user is just effectively streaming a session to themselves, they're able to increase their time to market value. They're making sure that they can produce products quicker, and they can do handovers to engineers in different time zones really quickly as well, without having to worry if a file is up to date or it's transferred, or the cost of doing that. So there's a huge benefit in using centralized resources, and there's also a huge benefit now of using resources to pull file servers together. So there's global file systems out there that can help customers utilize different Azure regions, but also share information, and that leverages things like Azure Blob globally. So yeah.
Great stuff. Thanks both. So that brings an end to our Q&A time of this session, and an end to you guys on screen. So thank you so much for doing that presentation for us, jumping through the demo and being so open and honest in the Q&A as well.
Thanks for having us.
Thank you for having us.
Okay, so the last few things that we're going to mention is around how can you now go ahead and learn a bit more about what we've been talking about. So other than the links mentioned by Simon and Hasifa, we've also got our UK Cloud Skills Challenge that you can go ahead and join. So that's at aka.ms/lunchbytes/CSC. You can also go ahead and check out our UK Developer Hub. And so that's at aka.ms/UK Developer. If there's anything else that you want to talk about, or you've got some follow-up questions, for example, don't hesitate to either drop them in the comments below or reach out to us at lunchbytes@microsoft.com. We'd be happy to help. The other area of learning is all about the communities. So if, for example, you're in the UK and there's a community local to you, then please go ahead and join some of these sessions. So you can find your local community at aka.ms/UK community, and there's loads of different great sessions going on throughout the year that you can go ahead and join. So perhaps someone will run a HPC session at one of the local communities as well. If you'd like any more information as well, feel free to reach out to us. So without further ado, thank you so much for joining us for today's session. You can join us again in a month's time. We've got Liam, who's going to be speaking to us about blue-green deployments with Azure Kubernetes Service. So once again, thank you everyone for joining, and we'll see you soon. Bye now.